Hey everyone, welcome back to The Explainer. I am absolutely thrilled you're here today because we're tackling what is arguably the most critical infrastructure shift happening in software right now. If you're a technical leader, a SaaS manager, or an engineer currently trying to figure out if something called MCP deserves a line item on your Q3 or Q4 roadmap, you are in exactly the right place. We're going to decode the Model Context Protocol, look at its massive 2026 update, and figure out exactly how it changes the way we build software.
Okay, let's dive right in. Here's our roadmap for the explainer today so you know exactly what critical technical ground we'll be covering. We're going to start with the AI integration problem, look at why MCP is being called the USB-C for AI, check out its lightning-fast adoption, compare it to traditional APIs, dig into that major 2026 security update, and finally, wrap up with a framework for implementing it safely.
All right, Section 1, the AI integration problem. To really get why this protocol is such a game changer, we first have to talk about the elephant in the room. That very real, incredibly painful headache engineering teams have been dealing with lately.
It basically boils down to this: M times N. Before MCP, if you wanted your SaaS product or your internal tools to talk to an AI assistant, you had to write a bespoke integration. But then another AI platform launches, and another. Suddenly, you're trying to connect M number of AI applications to N number of internal tools. If you multiply those out, you get an unsustainable quadratic scaling nightmare of custom integrations that simply cannot be maintained. Which leaves pretty much every engineering team staring at the whiteboard, asking this exact pivotal question: how on earth do we stop writing custom integrations for literally every new AI model? We can't just keep building point-to-point connections every time a new version of an AI agent needs to, say, read our database or create a support ticket.
That brings us to Section 2, the USB-C for AI. Enter the hero of our story, and the elegant solution that is actively eliminating this massive bottleneck. So, what exactly is the Model Context Protocol, or MCP? Basically, it's an open specification. It gives AI models one consistent, standardized set of rules to access resources, use prompts, and call tools. Instead of those M times N integrations, MCP shrinks the workload down to exactly one integration per tool. You build it once, and boom, any MCP-compatible AI application can instantly understand and use it.
And this brilliantly illustrates the concept. People are calling MCP the USB-C for AI. Think about your desk before USB-C. Every device needed its own specific cable, right? It was just a tangled mess of incompatible wires. Well, MCP does the exact same cleanup job for software architecture. One protocol, many tools, and absolutely no bespoke wiring required for each new combination.
Let's pop the hood for a second. The architecture relies on three moving parts. First up, the host. This is the AI application itself. Think Claude, ChatGPT, or your IDE like Cursor. Next, you've got the client, which lives inside the host and manages connections using a JSON RPC-based messaging format. And finally, the server. Now, this isn't some massive standalone backend. It's just a lightweight adapter that exposes your external systems, like Slack, GitHub, or a Postgres database, so any MCP host can instantly talk to it.
Moving to Section 3, lightning-fast adoption. Usually, developer standards take, years to gain traction, but the commercial urgency behind AI caused MCP to just completely break all the rules.
I mean, just look at this timeline. It is wild. Anthropic only open-sourced MCP back in November of 2024. By early 2025, OpenAI was fully on board, adopting it across its Agents SDK and ChatGPT. Then, in December 2025, the whole thing was donated to the Agentic AI Foundation under the Linux Foundation. By mid-2026, native support across all major AI vendors, with tens of millions of SDK downloads. It literally went from an experiment to an absolute industry necessity in under 2 years.
So, the crucial takeaway here is this. If you're wondering whether it's safe to invest your team's precious engineering time into this, it absolutely is. Look at the names backing this: AWS, Google, Microsoft, OpenAI, Anthropic. This isn't just one company's pet project anymore. It's vendor-neutral infrastructure governed by direct competitors who all sat down and agreed to play by the same rules. All right, Section 4, MCP versus traditional APIs. Now, as MCP has blown up, a really big misconception has popped up, and we need to tackle it head-on. People are asking, does this mean my current APIs are obsolete? Let's clear that up.
Now, what's really interesting here is the contrast. Traditional APIs, they are designed for us, developers. You read the docs, you hard-code the fixed endpoints you need, and you call it a day. MCLCP, on the other hand, is built for AI agents. It relies on dynamic discovery. That means the AI client queries the server at runtime, asks, hey, what tools do you have? And then decides completely on its own which tool to call and when.
So to be absolutely perfectly clear, MCP does not replace your API. Actually, scratch that. It needs your API. It's simply a self-describing layer that sits entirely on top of your existing infrastructure, giving AI agents a standard way to find it. But here's the catch. If your SaaS product doesn't expose an MCP server, modern AI agents effectively cannot see your data. You'll be left entirely out of AI-driven workflows. Section 5, Security and the 2026 Update. Because this protocol moved so fast into enterprise production, it definitely hit some growing pains. Time for a quick reality check.
You see, early MCP deployments ran on a stateful design, mostly running over Studio on developers' laptops. But as cloud-scale enterprise traffic hit, that legacy design really strained under the weight. So the July 2026 specification overhauled the whole protocol to a stateless, cacheable, web-like architecture. It even brought in powerful new extensions like tasks for long-running operations. But a quick heads up, this new stateless core is not fully backward compatible with those older legacy servers.
And look, that rush to scale brought some pretty harsh security realities. Researchers literally logged incidents of cross-tenant data exposure in early deployments. When you overexpose destructive tools, handing out write access just to be safe, you massively expand your attack surface. MCP has to be treated like critical production infrastructure. It needs the exact same rigorous authentication and tenant isolation reviews as any major customer-facing API, no exceptions. Which brings us to our final part, Section 6, Implementing MCP Safely. Knowing the risks and the massive rewards, how do we actually do this right?
Let's look at how this builds into a really precise 6-step playbook. The folks at 200OK Solutions laid this out perfectly to help teams get it right on day one. First, identify the workflow that actually needs an AI agent. Second, map it to an existing API that already handles rate limiting and auth. Third, build against that new 2026 stateless spec so you aren't immediately racking up technical debt. Fourth, scope those tool permissions incredibly tightly. Treat every single tool as an attack surface. Fifth, test with multiple AI hosts to make sure you avoid vendor lock-in. And finally, publish, monitor, and set up clear governance.
Because look, MCP is absolutely here to stay. It's governed by the Linux Foundation, and it is actively dictating how AI interacts with the world's software. So I'm going to leave you with this final critical thought to take back to your engineering teams. Is your data ready to be seen by AI? Take the time to evaluate your infrastructure, lock down your security posture, and get ready for the new standard of integration. Thank you so much for joining me on this explainer, and keep learning.